All right, here's a video on some of the software design stuff I'm working through. So yeah, one of the hard things about software design, particularly when you're building it, it's like it's complex and you don't all the thoughts aren't formed and things you think one week are out of date by the next week because you realize it was wrong and all that. So it's hard to get across all the thoughts and then the thoughts get out of date quickly. But here's an attempt because there is some interesting stuff here. So the last video, the August 7th demo, I showed these apps. So everything works, but the problem there is when you're building stuff fresh, you're dealing with all these multi-dimensional problems and you're trying to build it into an app. So you're focusing on everything, not necessarily each individual piece. And then the goal of this library is to make it very nice to make new apps. So like here's 3 apps, but then there's also the terminus and the relay. So that's 5 apps that have shown off. But then kind of looking at the code, they're all kind of like spastic and just not very cleanly expressed, particularly in the protocol stack, because you're worried about everything all at once and you're not zoomed into one particular aspect. So in particular, the protocol stack needed to be rewritten because it was a little bit buggy and it just wasn't expressed cleanly, and then just too much of it is duplicated across these different apps. So then the next person that wants to write an app is going to have to do all the same garbagey stuff, and that's really just not good. So that kind of defeats the purpose of making it easier to write cool money apps. So what I've done. I rewrote the relay with the new stack, which I'll get into. So the relay code is there, and like I can connect to it. So it's trying to rendezvous, and then I have just a test program to meet it and do the rendezvous, and I have it delayed for 3 seconds. So there finally connects after 3 seconds. So what I'm doing is I'm writing the new protocol stack, but I'm using the old protocol stack, which talks the same thing. It's just written poorly. Talking to the new stuff, which is written better. So like the old stuff becomes kind of like the test thing that you're throwing commands at to see if you're throwing commands and responding correctly. And then so you're rewriting the client to that. But then once this guy's up to snuff, then you rewrite this guy in reverse. So there's sort of this I don't know, ladder climbing, what's the right word? Piggy leapfrogging type thing that's going on. So I'm working through that, really trying to get the code right down here in Python, and then once the objects and code structure as well, then it becomes an exercise of transcribing that into Python and doing that here. And then also so this is one specific application, the opinion buyer and seller, and I really want to separate those aspects out such that if somebody has a new idea, whether that's streaming video or they want to play poker over Moneysocket or something like that, they can leverage all the underlying stuff and just write sort of the poker extension on top of Moneysocket. So yeah, I'm trying to do it in a way that caters to that. The way these apps worked, it was kind of mashed in there without being thought through too well. So it needed to be done better. So again, the frustrating part of this is like I'm not adding any new features. I'm making it work exactly the same. I'm just making the code higher quality and the code that's easier to then write subsequent applications. And then also, be less buggy and all that. When you have a big blob of code where all these random things are happening, that's where all the bugs happen. If you have like nice broken apart things where the concerns are separated, the bugs are contained such that you're only thinking about one problem at a time, and yeah, that's when you don't get sideswiped by something you didn't anticipate, because within that box you can anticipate everything. So that's just an argument for good modular code. So what I'm doing, because this is a communication protocol, layered architecture is typically what you see for communication protocols. The OSI model, for example, is one such thing where there's layers built on top of it. I mean, and the analogy between this and that isn't perfect. Like even within particular layers, there's sub layers. So this is sort of like there's the web sockets, and then this is Moneysocket, which is a layer on top of that. But even within WebSockets, there's all kinds of different layers, and then within Moneysocket, of course, there's now going to be a whole bunch of different layers. So it's a good abstraction that manages complexity well for this particular thing. And then I'm also, like, I spent a good chunk of my career working on a piece of code that implemented the SCSI initiator stack. And some of the words and concepts I've kind of borrowed just from that past experience, because that'll set, not that it's relevant now, but like if this protocol takes off down the road in 5 years or whatever, questions of like high availability, high throughput, and all that become relevant. So kind of taking some inspiration from this architectural model at least sets it up in a good direction that we can go deal with that at that time. So yeah, the word nexus. So there's ITLQ nexus. It's kind of a weird thing, but I've kind of used it, and then just the different layers, application layer, protocol, but then all the sub layers is what we're going to start to see here. So I did this diagram. This is actually updated from what I shared in the Telegram. Because the actual implementation, like, I kind of merged these two stacks into one, just because that made more sense once it was finally all coming together. So I have the relay application, and now I've got these layers. So I'm just going to jump over to this other diagram for a second. So I've got this kind of abstract notion of a layer, of which I've got many different expressions of it, but they're all subclasses of what I've called a protocol layer. So a protocol layer defines the upwards and the downwards. So the notion we want to stack layers, but a bottom layer provides service to the above layer, and that layer does its thing and then provides a service to the above layer. So yeah, each one of these is there, and they're meant to have a layer below them that throws them what I'm calling a protocol nexus. They wrap that nexus and throw it up to the above layer. So hopefully I'll do my best to try and explain how that works more practically in Moneysocket. But yeah, like the idea, like there's a bunch of these layers, and the idea, if you're making an app, you're kind of mixing and matching them of like what you need for your particular app and component, and you're stacking them up in a particular way. And sometimes it can get a little more complex. This is sort of how I have the terminus going. But yeah, like the library provides all these things, and it'll provide these couple example apps for you to look at the source code, and you'll see that, okay, yeah, the wallet grabbed all these layers, outcoming, incoming. It's tracking balances, so that's how that works. But yeah, the idea is the wallet has very minimal code, and then all the complexity gets brought in, ready to go, as in the form of these layers, and it solves most of the problems for you. So yeah. So we want, depending on the application, you choose the layers and you arrange that. So of course, the relay and the terminus are particularly important apps. And then once we get into this buyer and seller, it's more bespoke. But yeah, as far as I'll start with the relay. So the relay takes incoming WebSocket connections. So this is the cloud relay that's going to help defeat firewall issues. So if a phone wants to talk to another phone and they're on different cell networks, they can always connect to a cloud node and then use that as a relay to find each other. So that's what I had set up. That's what I showed in the demo. So they accept incoming WebSockets, and then each phone or device will use the rendezvous protocol to say, hey, I'm looking for my friend by this rendezvous ID, and then the other guy will come in, hey, I'm looking for my friend by this rendezvous ID. The relay matches those two people together, and then from there, all the commands from one is forwarded to the other, and vice versa. So that's one relay. It's fairly simple. Now on the terminus, so that's providing the actual Lightning Network service. There's sort of the same problem as what I noticed, and so in the first demo, I kind of implemented sort of the same thing in two different ways, and I realized, wait, these are the same thing, so why don't they have the same piece of code rather than two pieces of code that work mostly the same? So really, what I did is I structured the terminus to have a relay built into it, and this is the same thing where if devices are connecting into the terminus, and they're looking for a specific account on the terminus that has a certain amount of their Satoshis that they're entitled to. It's the same problem at a connect in. It's like, hey, I'm looking for my account, and here's the rendezvous ID. And then the account would also register in and say, hey, I have this account of this rendezvous ID. When you find my friend, connect them in here. So that's really the same thing. I get this relay layer with the incoming rendezvous. So it's the same layer, same relay layer. And we have the same incoming WebSocket layer. So when they connect in, it's like, hey, I'm looking for my friend. And then I had to invent this, this local layer. So rather than it sending stuff over WebSocket, within a program, it can send stuff. It actually skips all the encoding and encryption and all that. Just to like, here's a message that I'm going to pass from this component to the other component of the same piece of software. So in the same way, this outgoing rendezvous layer registers with the this inbuilt relay using the rendezvous protocol. Okay, so that's how we get things connected. But then we need to also connect providers and consumers. So the provider is the provider of the wallet services, and the consumer is the consumer. I think these terms are more useful than the wallet and service. I think the way this is going, it's sort of become provider and consumer. Provider is the wallet, consumer is the service. But yeah, you do need two words to kind of highlight the asymmetry of the protocol. The protocol has something that's providing services, and then there's a thing that's using those services. So that's consumer and provider. So the way this layered protocol works is, okay, the rendezvous protocol happens, and then, okay, we've achieved rendezvous. But then the next step, so that's when the rendezvous nexus then gets passed to the above layer. So in this case, the app, this will pass it to the consumer layer, and this will pass it to the provider layer. And then we have to do a provider-consumer handshake. So the provider will be like, hey, I'm looking for a consumer. So I'm going to send that message, and this guy will be like, hey, yeah, I'm a consumer, or I'm not a consumer, so therefore an error. But yeah, I'm a consumer, so here's some details about me. So the provider then is attached to the consumer. And then it throws it up to the next layer of the terminus of like, when somebody comes in and requests, I need an invoice, that goes to the terminus, which will then check to make sure that user's entitled to the balance, but then actually go reach into the daemon to pull them a Volt 11 invoice and send it back. So that's the terminus. And then also when stuff gets paid, or either an incoming thing or we're paying outgoing, then yeah, just the balance needs to be updated in the protocol. So here, like I was showing over the socket, when the balance gets updated, it has to send out a message. But yeah, every time something gets bought, it updates the new balance. So that's the responsibility of the terminus. So yeah, that layered architecture really serves to separate those concerns. All right, yeah, I'm going on 13 minutes. So yeah, I'll just talk about just these extension layers. So in the case here of a buyer and a seller, these guys need to talk. And so they have the context of being able to talk, consumer provider, and be able to, pay each other. But then it's the question of what are they paying each other for? And then like, how is the good delivered in return and all that. So that then becomes what I'm calling an extension layer that sits on top of the consumer provider. So there's the buyer extension layer and the seller extension layer. So they can send additional messages of their own definition in conjunction with the actual payments, such that you can build custom applications that have custom contexts. So if you as a developer were trying to build a service, you then ship the buyer both ends of this app that talk your own protocol that you've defined, and then you can have economic interaction in that regard. So the example of that is Sparkshot. We have our Sparkshot server, which sells pixels, and then our Sparkshot browser client, which allows you to select and add pixels to your shopping cart and type your message, and then sell. That's the buyer, and then the seller is our server. So if we were to do this with Moneysocket, we could define all of SparkShot as an extension to Moneysocket. Now I believe that's still optional. Like you could have you could implement your app as an extension of Moneysocket, or you could just embed Moneysocket in your app if you have your own custom ideas. So I think like it can work either way, and there's no reason how to do it. It just depends exactly what you're doing. But yeah, I think for getting off the ground, it's like here's how you do extensions. You could pack it and do your own thing between your buyer and seller, but here's at least a way that works that we've thought about to make it easy for you. Okay, so that's 15 and a half minutes. So I guess I'll end it there. So yeah, happy to carry on this discussion in the Telegram.